As a clinical trials manager, I see firsthand the issues in clinical trial management. To solve these issues, I'm going to present a Gen AI supported decision tool called the Clinical Trial Study Classifier and Staffing Advisor app. This app applies the process analysis concepts to a real business process, more specifically, clinical trial operations and how studies are prioritized and staffed. Staffing challenges in clinical trial operations are not caused by insufficient flexibility, but by insufficient system-level decision support. The Clinical Trial Study Classifier and Staffing Advisor app applies course-based process analysis and generative AI to standardize how studies are evaluated for staffing risk, workload variability, and operational impact. By making trade-offs explicit, across enrollment volume, variability, and burnout risk, the app enables proactive decisions before problems emerge. Clinical trial operations are a high variability process, with studies differing widely in enrollment patterns, study visit intensity, predictability, and coordination demands. Despite this, staffing decisions are often made informally based on intuition or urgency rather than a consistent framework. This leads to three recurring problems. First, studies with very different operational profiles are staffed the same way. For example, a high predictable, high enrollment study may receive the same staffing model as a low enrollment study with sporadic high intensity visits. Second, variability is absorbed by people rather than by the system. When enrollment surges or visits run long, staffs are compensated by working late or shifting priorities. This does create hidden cost and burnout risk. Third, over time, this overextension is normalized as flexibility, masking structural inefficiency and discouraging process redesign. Basically, the current system is built to keep everyone busy all the time, instead of being built to handle ups and downs without things breaking. Using the concepts and tools from this course, I designed a Gen AI supported app that standardizes how clinical trials are evaluated for staffing risk, workload variability, and operational impact. On the screen is a visual mock-up of the Gen AI dashboard built in Hunch.Tools. On the left, managers enter key study characteristics such as expected enrollment, visit intensity, predictability, and dropout risk. On the top right, the AI assessment section represents the Gen AI reasoning layer, which evaluates these inputs using operation management principles like variability, capacity strain, and flow risk. As you can see, this specific study, the study is classified as a Tier 3 high risk, high variability study. On the bottom right is the results dashboard. Recommendations are also provided in this section, such as having dedicated study coordinators or if a study has a risk for burnout. Below that, the managerial insight box explains the trade-offs in plain language. Overall, the layout separates inputs, analysis, and action, making system-level thinking part of everyday decision-making. Looking further, several core course concepts directly inform how this process is analyzed. First, process segmentation. Rather than treating all studies equally, the app classifies studies into operational tiers based on workload characteristics. Second, variability management. This app focuses on unpredictability rather than averages, reflecting the course insight that variability drives congestion and delays. Third, capacity and utilization trade-offs. The app highlights cases where high utilization may appear efficient, but actually reduces system resilience. In conclusion, the staffing challenges observed in clinical trial operations are best understood as system design problems rather than failures of individual flexibility. This app demonstrates how applying the process analysis concepts from this course, supported by generative AI, can bring structure and consistency to staffing decisions in a high variability environment. By standardizing how studies are evaluated for staffing risk, workload variability, and operational impact, the app makes previously implicit trade-offs visible. As a result, managers are better positioned to anticipate strain, allocate capacity deliberately, and reduce reliance on reactive interventions. Ultimately, this approach reinforces a core course insight. Sustainable performance is achieved not by asking people to absorb variability, but by designing systems that do so intentionally. Thank you.